In this section, we're finally going to start talking about moles. So we're not talking about the animal mole, we're talking about the chemical unit. So talking about moles, you also have to talk about atomic mass. So when we talk about atomic mass, you have to think that it is absolutely tiny. Okay, so it has its own unit. It's called atomic mass units, or AMUs. Okay, now this is like times 10 to the negative 7 to 11 kilograms, so it's absolutely minuscule. Okay, but instead of basing it off of any macroscopic standards such as the kilogram, scientists actually base it off of carbon-12. Okay, so you'll see that a lot, that they base a lot of stuff off of carbon-12. It's just kind of a standard, okay, and it's a pretty good standard. So the standard unit used to compare units of atomic mass is carbon-12, which has a mass of exactly 12 atomic mass units, or 12 AMU. So 1 AMU is equal to 1/12 of the mass of a carbon atom, carbon-12 atom. Okay, so remember, in a carbon-12 atom, it has 6 protons because it is a carbon atom. And then you take your mass number, which is 12 in this case, and subtract out your number of protons, and that's your number of neutrons. So in this case, also 6. Okay. And then you also have your atomic mass. Okay, average atomic mass. Now this is something that you use a lot more frequently than just the atomic mass. Excuse me. The atomic mass of any atom, any isotope, is just the protons plus the neutrons. Now the average atomic mass is actually a weighted average, so it takes into account the relative abundance of each isotope. So if you have, say, carbon-12 is 90% more naturally occurring, it's found in nature so much more frequently than carbon-14 is, then your average atomic weight is going to be closer to 12 because it's more common. Okay, but you do still have to account for the 14, carbon-14. So when you do these, the average atomic mass, again, depends on the mass and relative abundance of each isotope. So if we have a problem here, copper consists of 69.15% copper-63, which has an atomic mass of 62.929601 atomic mass units, and it's also 30.85% copper-65, which has an atomic mass of 64.927794 atomic mass units. So you have to figure out the average atomic mass. So let me get a pen here. Okay, so first thing you want to do is take your percentages and you're going to turn them into decimals. So this is 0.6915 and this is 0.3085. Okay, and now you are going to take those decimals and multiply them by the atomic masses that they go with. So we have our 62.929601, multiply that by our decimal here, 0.6915, and then you're going to add in the second one. Okay, so we have our 64.927794, and that decimal is 0.3085. Okay, so once you plug that into your calculator, multiply each atomic mass unit by its percentage in the decimal form and then add them together, and you get that the average atomic mass for copper is 63.55 atomic mass units. Obviously that's rounded, okay? But So this one is easier than a lot of other math that we've been doing, okay, but still important to know. And oftentimes you will, well, be asked more to figure out what the element is based on its average atomic mass. So you'll have to calculate average atomic mass and then match it up with an element or, something along those lines. Okay? All right. So now we're going to talk about the mole itself. So the mole is actually an SI unit. It is one of the 7 standard SI units, and it is the SI unit for the amount of a substance. So a mole, yeah, I know, it's a great abbreviation, just knocks off the E, is the amount of substance, or its standard is the amount of substance that contains as many particles as there are atoms in exactly 12 grams of carbon-12. Because, why not just keep the 12 going there? Really no other reason to have 12 grams there. But, okay. So basically, a guy named Avogadro figured that out. Not avocado. Okay. But he figured out that there are 6.022 times 10 to the 23rd atoms of carbon-12 in 12 grams of carbon-12. Okay? Don't ask how he did it. It's kind of annoying, but yes. So his name does sound a lot like avocado. Okay? In fact, if you have 6.022 times 10 to the 23rd avocados, what do you have? That would be a guacamole. Ha! Okay. So, Avogadro's number is now known as the number of particles in exactly 1 mole of a pure substance. Okay? So, we don't really think about 10 to the 23rd in normal day, okay, in our normal everyday lives, just because it's such a large number. And you see that 23 up there and just kind of, whatever. But if the population of Earth is roughly 6 billion people, a mole of people would be about 100 trillion Earths. So this is just to give you kind of an idea of the scale that we're talking about here. A mole of seconds is equal to 10 quadrillion years. If you had a mole of dollars, you could spend 1 billion per second for over 19 million years before you ran out. And then stack a mole of pieces of paper on top of each other, and the stack would travel to the moon and back 80 billion times. So, kind of the new around the world in 80 days sort of thing, but yeah. Anyway, so, as you are all aware already, Mole Day is October 23rd. Okay, so times 10 to the 23, 10/23, October 23rd. And yeah, it's a great science holiday. So happy Mole Day. A little bit late, but yeah. Alright, so you'll also have to talk about something called molar mass. So the molar mass is the mass of 1 mole of a pure substance. Now this is relatively easy to calculate. It just comes straight off the periodic table. Okay, so molar mass usually has units of grams per mole. Okay, hence the molar mass. Molar referring to the moles and mass in grams. Okay. And the molar mass of an element is numerically equal to the atomic mass of the element in atomic mass units. Okay, so if you look at your handy-dandy periodic table, okay, we've already talked about the atomic number, which is the number of protons in the nucleus. Also happens to be how the periodic table is organized. So that number in the upper, it's usually the upper left-hand corner, is your atomic number. Okay, so we've talked about that. And then you'll have your atomic symbol in the middle and the name of the element underneath that. And then there's that number that comes underneath the name of the element. Those are your molar masses for each element. Okay, so if you look at the periodic table, you'll see that hydrogen has a molar mass of 1.008, and that's grams per mole. Carbon has a molar mass of 12.011 grams per mole. If we pick bromine, has 79.904 grams per mole, so on and so forth. Okay? So, using these molar masses from your periodic table, you can actually do gram to mole conversions. So asking somebody to measure out, say, 5 moles of a substance is not all that helpful because we don't have a good way of actually measuring moles. So you actually would have to convert that number of moles into grams. Okay, because then you can just go ahead and use your grams, and that's relatively easy for us to do. So, molar mass will actually work as a conversion factor in these chemical calculations. It is grams over moles, okay, so it's some number of grams, and then it's almost always going to be over 1 mole. So this is it's more important that you keep your units lined up correctly than trying to figure out the numbers right off the bat, okay? So you can almost always put 1 next to moles and then figure out the grams from there. So the molar mass of helium is 4 grams per mole. And you can see this is written more as a conversion factor, so you have 4 grams of helium over 1 mole of helium. So how many grams of helium are in 2 moles? Okay, so at this point, you've got 2 moles is your given, so 2 moles, okay, and you're looking for grams, but you need to cancel these moles. So you've got moles on top here, okay, this is moles on top, and then you need moles on the bottom. So using your conversion factor here, you have 1 mole on the bottom, and you have 4 grams on top. So how many grams of helium are in 2 moles? It's just 2 times 4, and then divide by 1. So it's 8 grams. Relatively simple, okay? So, you can also do conversions with Avogadro's number. This is where it gets super fun, and you really do have to know how to use the exponential functions on your calculator. So if you need a refresher on that, please ask me, okay? Because these are so much easier if you know how to use that properly. So Avogadro's number can actually be used to find the number of atoms in a substance given either the mass or the moles of the substance. If you're given mass, you will have to convert to moles, and then you can convert to atoms or particles or anything like that. So Avogadro's number is generally expressed in units of atoms per mole. It can also be photons per mole, can be particles per mole, anything tiny like that per mole. Okay, so if it asks you how many atoms are in 6.54 grams of carbon, okay, so we're given our 6.54 grams, okay, and then we need to convert that to moles, okay. So with this, you have grams on top, okay, and you need to convert to moles. So grams have to go on the bottom, and if you look at your periodic table, this is 12.011 grams in 1 mole. Okay, so that will convert into moles. And then you can use Avogadro's number of 6.022 times 10 to the 23rd, got it in there, over 1 mole. And that will convert to atoms. Okay, so if you do 6.54 divided by 12.011, and then multiply by 6.022 times 10 to the 23rd, you get 3.28 times 10 to the 23rd atoms of carbon. And that's where we're going to end this video, and we'll pick up in the next video.